Now, I mentioned previously there's a thing about references, specifically hash references and array references, that you can create nested structures. So let's explore that. Let's say I have a key A pointing to 1, B pointing to 2, and what if I wanted a key C that points to another hash reference or a hash structure, so let's say. It's possible with hash references. So basically, what you're doing here is you're pointing to a reference in memory, right? So you're not kind of merging your structure in. You can say AB is pointing to numbers and C is pointing to reference. So you can say new equals 1 and new 2 equals number 2. And if we try to print out the hash reference now, so hashref, save this, print it out, is going to say, here are my original values and here's the new C value we added. It's nested, and we can also introduce more nested values, such as deeply can point to, let's say, array reference with values 3, 4, and 5. I save this, I print out my hash, and here we go. Our key is now pointing to hash reference. And as I mentioned before, this can be extremely useful when you need to store information in object pattern, where keys are pointing to various types of data or information about the object you're working with. The question is how, for example, we could access the value of C, so the key C in that hash reference, the value of key new2. So what you could do is the same thing as we looked at the dereferencing, is you use arrow syntax, you say key C, and then you keep dereferencing with arrow syntax, saying my new key 2. If I print this out, we have the value of 2, which is under the key new 2. The same thing if I want to go deeper and say I actually want to access the deeply key, which holds array ref. So since we know it's array ref, what we need to do is we use the same arrow notation and we access the value by index. Let's say 2, which is going to be 0, 1, 2, meaning it should be value of 5. We save that, rerun it. Oh, and looks like we have syntax error. So we are accessing our hashref key C, which is here, and then we say there should be a deeply key on the new 2, which is actually pointing to value of 2. What we need to do, we actually need to access the deeply on the C structure. So if we change that, we rerun it, and here we go, the value of 5. And the same goes for arrays. So if we wanted to add nested data structures, such as is my array ref, and I'm going to say first value is just going to be 1. The second one can be a hash ref, and we're going to use this quote word syntax, which we're going to spread in some strings into the second element, which is A, B, and C. The third element can be a hash ref, which says A with value 1, B can be a nested hash ref, which has a key C that points to hashref that, let's say, has an element of hashref again with a key A pointing to a new hashref, and so on and so on and so on. But you get it. The point being is that when you're working with hashrefs, you can nest the data structures as much as you want. If I try to print out this structure, which is array ref, and I save this, here we go. We have first items, index position 1 is a value 1, then it has a hashref with these 3 strings, ABC, and then we have this nested structure, which is A holding a hashref value. And if we try to access this, and let's add a value, for example, like find me. So it's going to hold 2 strings, find and me. So let's look into how we can access these structures. We're going to start with dereferencing 0, 1, 2. So it should be at index position 2. We move forward. We want to access a key, which is B. So we type key B. We then want to move deeper, access the key C. And the key C is actually pointing to a array ref, which we can see here. And the first element is a hashref. So we access the first element and we know this is a hashref. And then we dereference that, and that one has a key A. And if we save this and print out, and here we go, it's going to say find me. Now, some of the very useful methods you can use when you're working with these references is called ref. So let me just clear this up a bit and let's leave the hashref only. So you can use this function called ref, which takes a value in between it, and you can add hashref. And what's going to tell you is that you're currently working with a hashref, right? So ref tells you if the data structure you're working with is a reference. In this case, yes, this is a hashref. You could be passing in array ref, save this, and this is anonymous array ref. We are not assigning it to a scalar, but that's fine. You can have anonymous references not belonging to any scalar. If you do this, it's going to say this is array ref. The same, of course, goes for scalar ref. You can use the same methods on references as you would use on your hashes or arrays. However, you always need to dereference your structure. What I mean by that is, for example, if you wanted to say keys on your hash ref, save this. So the console is going to say, you're trying to use keys on scalar and that's forbidden. And you can easily avoid that by just saying that we want to dereference it by some of the ways we looked at before, for example, array notation, percentage sign, and star. So we save this and we run it, and here we go. We see keys BAC. The exactly same thing would be for if you wanted to call the values, you also need to dereference this. So delete things such as hash, ref, equal, let's say we want to remove B key and we print out just the hash ref. Here it is. You have the key C and only key A. So B was deleted. The same would be, for example, if an element exists, but remember, you also need to dereference it with this arrow notation. So this is it for this lecture. We looked at what are references, how you access and interact with references, and why they are extremely useful.